So good afternoon everybody, myself Acharya Vishwan. This is NCRT question discussion. So let's begin with the alternating current chapter. So firstly question are about DCs and ACs. Then we have questions on application of AC to a circuit, variation of current, graphical variation, question based on amplitude, variation, AC current, DC current, etc. Then we have average value, RMS value. Then we have questions based on application of AC to a simple resistor, its phasor diagrams and various questions based on that. Then we have Kirchhoff's law on inductor attached to an AC circuit. Then we have the concept of inductor and values of AC current through it in different cases. Then we have phasor diagrams for pure inductive circuit. Then we have AC circuit attached to an inductor and its diagrams for the current, phase differences, etc. Then representation of the coil in different cases, the questions based on the above question, the variation of current in different time intervals. Then we have AC current across capacitor, values of current and potential difference. Then we have questions based on capacitive reactance, its graph, phasors. Then we have graphical based questions on that. Then we have certain graph based questions on capacitors. Then we have charging capacitor, power supplied to capacitor in different cases, current in the circuit, variations of current. Then we have questions based on charging, clockwise, anti-clockwise. Then we have inductor coil problem. Then we have series RLC circuit problem. Then we have relations between the net voltage, phase difference, various questions based on that, especially based on phase diagrams. Then we have numericals problem based on that. Then we have peak current in different circuits, oscillations of that. Then we have damping. Then we have resonance. Then resonance we have. Then we have questions based on maximum and minimum current, symmetry, its distribution. Then we have resonance, half power points, half power frequencies, sharpness of resonance, quality factor. Then we have a numerical problem based on capacitor and resistor problem. We have to calculate current, impedance of circuit, RMS voltage, sum of the voltages. Then we have phase difference based questions. Then we have questions based on a general circuit and the power, instantaneous power in the circuit. Then questions based on average power. Average power using different permutations and combinations. Then we have power factor. Then we have problems based on voltage and current phasors. Then we have questions based on power loss in a series RLC circuit, numerical problems based on that, calculations of phase difference, power dissipated in the circuit, power factor, resonant frequency, and angular resonant frequency of the circuit, resonance in AC circuit. Then we have questions based on current in the circuit. Then we have LC oscillations, its equation, differential equations, natural frequency, solutions of the equation, fully charged capacitor, then the value of phase difference, fully uncharged, different cases, current in the circuit, energy stored as a function of time. Then we have questions based on LC oscillations in different cases, graphical questions on LC oscillations. Then we have energy stored. Then we have energy stored increase or decreases in different intervals. We have the graphs for that. Then maximum and minimum energy. Then we have frequency of oscillations, then energy of the system, then LC oscillations, differential equation for that, the angular frequency of oscillations, then mechanical system equivalence, then electrical system equivalence. Then there is analogy between electrical and mechanical oscillations, then analogy between them, displacement, etc. Then we have concept of total energy of the system. Then we have concept of radio television transmitter, differential equation in RLC circuit, displacement is equivalent to what, concept of forced oscillations. Then we have sum of energies on that. Then we have coils can be wound. Then there are questions on transformer, primary and secondary coils. Then we have questions based on these basic problems. Then we have flux related problem. Then we have certain questions based on primary and secondary voltage, then using power conservation theorem, the conditions for that, step up and down transformer, then values for step up and down transformer, how they are step up and step down and what factor it depends, the numerical problems on that, then energy losses, how to avoid them, flux leakage, then concept of wire use for winding, then we have alternating currents, magnetic flux eddy currents, then we have magnetization of core, then large scale transmission and distribution of electrical energy, voltage output of the system, then we have general concept of AC voltage at our home, then algebraic problem based on an AC applied to a resistor, current, power, average power, RMS value, average value of current. Then we have current in the circuit for pure inductor, current, power loss, etc., average power. Then we have peak current, then we have phase difference, then we have impedance, then we have impedance of circuit, resonant frequency, quality factor, free and forced oscillation, then relation between primary and secondary current for step up and step down transformer, dimensional formula for voltage SI unit, for current SI unit, then inductive reactance SI unit and CGS unit, then it's SI unit of resonant frequency, dimensional formula, quality factor, SI unit of quality factor, dimensional formula for power factor, SI unit of power factor, then peak value, RMS value, ratings, then we have question based on DC and AC, then we have calculations for different net voltage in AC circuits, then we have questions for resonance circuits, input and output, and there are a total of 509 questions. These are the answer keys for that. So we have tried our best to make sure that you just optimize your time and energy and prepare NCRT in an object-oriented manner in a less time requirement. There should be a requirement of less time, and you should be able to study without any burnouts, anxiety, or any sort of negative feelings. So we have put our best efforts to make sure that we create something which is of use to the Gen Z, and so that you can perform better, and just need to focus on your performance rather than collecting information, choosing from this source and that source. We have tried our best to make sure that we create an optimized information source which is equivalent to a replacement of NCRT, although you should read NCRT once, but if you are interested in a quick session which is quite comprehensible and which is quite sufficient, more than sufficient, then I think you can use this source. So it's just a tool to optimize your time and energy, and to prepare you especially for problem solution based approach, and it's based on problem solving skills. So if you want to study just to perform good in exams, then you should use this. I think it will prove to be an optimization tool in improving your problem solving skills and preparing physics for competitive exams. Thank you and have a nice day.